This is from Julie, who would like to know, how do you wear the moniker of celebrity physicist or public scientist? Is it a burden or a privilege? Would you rather be in the lab more often?
Well, I'm a theoretical physicist, and people ask me, what do you do for a hobby? Well, I like to do theoretical physics. It is my hobby, but it's also my avocation. And so that's pretty much what I do for a living. Now, I realize that if you are a public figure, there's a purpose behind that, and that is you want to educate the public to the possibilities of science, because where does wealth come from? All this wealth that we see around us. Some people say, politicians say, that wealth comes from taxes. But taxes simply rearrange wealth. You rob Peter to pay Paul. Economists say that wealth comes from printing money. But that simply means that you have to pay interest on your great-grandchildren's investments. That doesn't mean that's a source of wealth. I say that we scientists have to tell the people that wealth comes from science and technology. And every time we physicists unravel a force, it changes human history. When Isaac Newton wrote down the laws of mechanics and gravity, he laid the groundwork for the Industrial Revolution, the greatest revolution in human history that lifted us from a poverty-stricken agrarian society into the machine age. And then when Maxwell and Faraday worked out electricity and magnetism, that unleashed the electric force, which gives us dynamos, dams, which gives us motors, which lights up our cities. When Einstein wrote down E equals mc squared, that helped to solve the mystery of the sun, the stars, the nuclear force. And now we're on the verge of a theory of everything. So every time we physicists unravel a force, we change human history. We physicists know this, but the public does not know this. And who pays our salary? Ultimately, the government and private industries pay our salaries, but they don't appreciate the fact that we are the generators of wealth in society, that we are the creators of all the abundance of wealth, computers, lasers, the internet. All of that came from the mind of a physicist. And unfortunately, we got lazy. In the 1990s, our machine, the Super Collider, was canceled. This multi-billion-dollar machine was canceled, and the Vatican of Physics went to Geneva, Switzerland, where we have the Large Hadron Collider. We got bored with raising money. We used to go to the Congress of the United States during the Cold War and say one word to Congress, Russia. And then Congress will whip out the checkbook and say two words, how much? That's the way it was during the Cold War. You wanted a machine? How much? The Russians have a machine, we'll give it to you. Those days are gone. We physicists now have to learn to sing for our supper. We have to learn how to engage the public because the taxpayers pay for our research. Let me give you another example. In the 1990s, there was this fierce debate about the Super Collider. In the last day of hearings, they were going to cancel the Super Collider, this beautiful machine of science. One congressman asked the physicist, and I quote, "Will we find God with your machine? If so, I will vote for it." Well, the physicist didn't know what to say. So he said, "We will find the Higgs boson." Well, you could hear the jaws hit the floor in the United States Congress. $10 billion for another goddamn subatomic particle. The vote was taken, our machine was canceled, and American physics, particle physics, was set back 2 generations. 2 generations we were set back. That's how devastating that was. Since then, we physicists have to go through our mind over and over again. How should we have answered that question? The next time someone says, "Will we find God with your machine?" I would have answered it this way. I would have said, God, by whatever signs or symbols you ascribe to the deity, This machine, the super collider, will take us as close as humanly possible to his greatest creation, Genesis. This is a Genesis machine. It'll recreate some of the early conditions of the greatest event in the history of God's universe, its birth. Instead, we said Higgs boson, and our machine was canceled, and we were set back 2 generations of physicists. What's the moral here? The moral here is that we physicists have to learn to sing for our supper. Stephen Hawking showed how to do it. Here was this top physicist at the cutting edge talking to children. Yes, that is the way of the future. We have to learn to sing for our supper.
Now, I wanted to go back just when you were mentioning there about the incredible innovations that have come from science, but it reminded me also of that. I can't remember who said it. The person who said the future is already here, but it's not evenly distributed. And that seems to be another issue, is that we've had these incredible insights, incredible possibilities of technology. And yet for a lot of people, I mean, for instance, in both the UK and the US, particularly countries with a huge disparity and an increasing disparity between the richest and the poorest. And there is a sense that the future is here, but not everyone has access to it. Not everyone has access in the US, for instance, to some of the remarkable achievements of healthcare. Do we somewhere along the line need to attach more philosophy, more ethics to these incredible advances that we have?
Well, yes, but there's also a flip side to the whole question. When technologies are first mass produced, they are expensive because you have to pay off the investors who invested in the technology. You have to encourage inventors to invent these things by rewarding them. And so there is a price to pay for inventions when they're first marketed. Then what happens is mass production sets in. Then we get the fact that products can be reduced in price because of automation. Look at the Human Genome Project. It cost $3 billion to sequence the first human being. $3 billion. People said that genomics is only for the rich. In fact, only for billionaires. Only Stephen Gates, only Bill Gates, and only Zuckerberg will have access to the Human Genome Project. Well, guess what happened? For $100 now, for $100, you can get most of your genes sequenced just by mailing in your spit. Who would have thought? What happened? Automation, mass production, competition drove down the cost. You know, back in the 1920s, I mean, back 20 years ago, when the internet was first coming out in a big way, people said the internet is for the rich. They called it the digital divide. Only rich people will have laptops. Only rich people will be online. Well, guess what happened? Children are online. If you're a kid and you're not online, you don't exist. You don't have a handle. You don't even exist anymore. In fact, at that point, I still remember that laptops were produced for school children, but these laptops would just sit in the schoolyard unused. Why? Because the teacher didn't know how to use the laptop and the kids were already online. Now even poor countries are getting access to this by the millions. In fact, you know that if you are poverty stricken in a poor country, you would rather have a cell phone than a bathtub. It's incredible. I saw the numbers. Poor people would rather have a cell phone than a bathtub because, well, you can always, use your neighbor's bathtub, but a cell phone, you need it because for life, for borrowing things, for making friends, for expanding your pool of acquaintances, you need a cell phone. It's a gold mine, that cell phone. So what we have here is the fact that automation, demand, artificial intelligence, mass production is driving down the cost of these technologies to the point where for $100, you can get a technology that once cost $3 billion. So there's hope.
Let's move on to now the next question. When you say where there's hope, we might need this because the next question is about consciousness. So either it's going to be over in 12 seconds or this is going to take us all the way to the end of the show. Jeffrey would like to know, where does consciousness belong in the theory of everything?
Well, just because you learn the rules of chess does not mean that you are a grandmaster. There's something called emergent phenomenon. In other words, if I get a bunch of molecules and I put them together, what do you get? Well, you get a gas, for example. But out of this gas, you can get hurricanes. You can get the weather, snowstorms, all sorts of anomalies that you couldn't necessarily predict ahead of time. And consciousness might be one of them. If I give you 100 billion neurons, 100 billion neurons, and just wire them up, you will find all sorts of bizarre phenomenon emerging for free. These are called emergent phenomena because of something called chaos theory. So this theory, the theory of everything, will give you the ground rules. It'll give you the rules of chess, but it will not give you all the bizarre twists and turns of emergent phenomena, especially when you put 100 billion neurons together in your head. All sorts of interesting phenomena come out, including consciousness.
Brilliant. We'll move on now straight to an infinite number of universes. That's what Jonathan would like to know. Are there an infinite number of universes?
Well, the short answer is we don't know, but there is an interpretation of ordinary quantum mechanics that says that we coexist with an infinite number of universes. Now, I once talked to Steve Weinberg, Nobel laureate, and he gave this example. Think of a radio. Your radio is tuned to one frequency. You can only hear one frequency, but surrounding your living room, there are hundreds of frequencies that you cannot hear because you're not tuned into them. You don't vibrate at the same frequency. You only hit one frequency in your living room. Now these vibrations, replace them with matter vibrations of quantum mechanics. The Schrödinger equation gives you all sorts of vibrations, electrons, protons, all vibrations, but you are only tuned to one frequency. And that frequency we call reality. But in your living room, you coexist with all the other frequencies, the frequencies of aliens, the frequencies of dinosaurs, the frequencies of pirates, but you can't see the dinosaurs. They're there, but you can't see them. And why not? Because you're no longer vibrating in unison with them. And you can even calculate, in fact, this is a problem that we give our students, calculate the probability that you'll wind up on Mars tomorrow. Because on Mars, you vibrated at a different frequency. It turns out, and you could do the math, you would have to wait longer than the lifetime of the universe for you to wake up on Mars tomorrow. But it's possible. It's a calculable number. So that's how strange quantum mechanics is. Quantum mechanics says that we coexist with an infinite number of universes. And yes, Elvis Presley is alive in one of them. This is crazy. But like I said, get used to it. This is just the way it is, folks.
Jake would like to know, do you have a personal view on the potential great filter that humans may confront one day?
What is that? The great filter? I don't understand.
Yeah, I'm not entirely sure what the great filter is either. So, Jake, send us what great filter is, what you mean by that.
Google it. We'll find out.
Michelle would like to know, have you referred to the theory coming... Oh, sorry, you have referred to the theory coming before the proof. Do you believe that non-physicists can have great theories? Is physics innate in our souls? Do we have the theories in all of us already?
Well, I like to think of it as trying to learn, let's say, French. That it's possible to learn about French civilization, about the great works of art of the French civilization. But if you want to understand the thinking process, then of course you have to learn how to conjugate verbs. You have to have a vocabulary. And the same thing with nature. If you want to appreciate the glories of nature, the sophistication, the beauty of nature, that's for everyone. However, if you want to understand how nature works, the mechanics of evolution, the mechanics of let's say, volcanoes and earthquakes and things like that, you have to pay your dues. You have to learn mathematics. Mathematics is the language of nature. Now, ultimately, we think that all these equations of mathematics come from one equation, the God equation, and of course, that's the topic of my latest book. But if you want to appreciate the consequences of the God equation, that's for everyone. The universe is there for everyone to appreciate. But let's face it, if you want to be a player in the game, if you want to create your own theory, then you have to know the mathematics. That is the language of nature, just like French is the language of French civilization. Sorry about that.
Jim would like to know, he says, how much do string theorists get on with supersymmetrists in real life conferences, etc.? Is it difficult?
Well, first of all, what is beauty? Beauty to an artist is something that is aesthetic, something that is aesthetically pleasing. To a physicist, beauty is symmetry. And what is symmetry? Think of a snowflake. If you were to rotate a snowflake, it remains the same. Take a look at a sphere. If you rotate a sphere, it rotates into itself. That we call beautiful. An equation is beautiful when we rotate particles into other particles, and the theory remains the same. Now, the biggest symmetry in physics is called supersymmetry. It's a symmetry of strings. Think of all the vibrations of the string. You rotate them in the equation, and the string equations remain the same. This is the biggest symmetry known to science, and it is the symmetry of strings. And so we think that at the beginning of time, the universe was like a crystal, perfectly symmetrical. Everything rotated into itself, and that was the crystal at the beginning of the time. What was the symmetry of this crystal? Supersymmetry. But there was a crack. There was an imperfection in that crystal, and for reasons we don't understand, it shattered. It shattered, giving you pieces everywhere, and that's called the Big Bang. And what do we do as scientists? We're trying to put those pieces back together again, one by one. We're trying to put those pieces back together again. I like to think of it as flatlanders, two-dimensional people living on a tabletop, cookie people living on a tabletop. There's a crystal that shatters all the components down on flatland. And over 2,000 years, flatland people assemble two big chunks of crystal. One chunk is called relativity. The other chunk is called the quantum theory, and they don't merge together. So one day, one flatlander has an outrageous idea, preposterous. People laughed at it. The idea is to lift one crystal in the third dimension, flip it in the third dimension, and bring these two pieces together. People said, ha, this is crazy. There's no third dimension. There's only two dimensions of flatlander. But on a computer, you can show that these two pieces, relativity and the quantum theory, fit perfectly if you lift one of these pieces into hyperspace, the third dimension, flip it in hyperspace, and bring it together. Well, we think that crystal is string theory. The symmetry is called supersymmetry, and we physicists are trying to lift not a three-dimensional crystal, but an 11-dimensional crystal to give you a theory of everything.
Wonderful. We have just time for one final question. Jake, we will come back. Your great filter question, by the way, Jake. Join us again when we've got Richard Dawkins with us to talk about Hitchhiker's Guide to the Galaxy, because I think that will be a good time to talk about the great filter. Now I've just looked it up. Sophia would like to ask, she says, to the extent that philosophy is father of science and may still inform it, are physicists trained in philosophy as part of the curriculum?
Well, the short answer is no. When I was at Harvard, I took a course in philosophy just to find out what all the excitement was about. And quite frankly, I was a little bit disappointed. I didn't see anything new coming out of philosophy. It's just like a lot of pretty words. However, Steve Weinberg, again, winner of the Nobel Prize, wrote a book, and he had a chapter called Against Philosophy. In other words, he said philosophy is useless. And he listed all the reasons why philosophy was not a guide. And in fact, I sometimes quote Einstein. And Einstein said that when he was young, philosophy was like honey. It was like honey, he said. At first, it's sweet, tantalizing, and then you realize it's all fluff. There's nothing there. Well, the irony is that chapter, Against Philosophy, a whole chapter ranting and raving against philosophy, is one of the most philosophical chapters I have ever read. It's beautiful. It's gorgeous, going through all the ins and outs of philosophy, all the arguments showing how they're wrong, and so on and so forth. But the whole chapter, Against Philosophy, is one of the most philosophical chapters that I have ever read. In other words, as Einstein once said, science without religion is lame. But religion without science is blind.
Wonderful. Thank you so much, Michio. I can see, by the way, that when we come back to do the next event towards the end of this month, I'm going to get new bulbs in some of these things. I've become very, very dark and somber during this. The God equation is out now. I should say this is not actually, this is the proof copy cover. Look up the God equation. It deals with a lot of things that we haven't mentioned tonight. We've only really got to the beginning of those things. Thank you very much for joining us. Thank you very much to the How To Academy, and thank you very much, Michio. Hope to see you all again soon.
My pleasure. Great honor.